Titanium, sleek, silver, and nearly indestructible, is one of the most extraordinary metals ever discovered. It's used in aircraft, spacecraft, medical implants, and even the latest smartphones. But have you ever wondered how titanium is made, why scientists call it the metal of the future, and what makes it so incredibly strong? In this video, we'll uncover the fascinating story of titanium, from its mysterious origins to its unstoppable rise as one of the strongest and most valuable materials on Earth. The discovery and origins of titanium. Our journey begins in the late 18th century, in 1791, when British clergyman and amateur geologist William Kroll made a remarkable discovery in Cornwall, England. While studying black magnetic sands along a riverbank, Kroll noticed something unusual, a metallic element that didn't match anything known at the time. It would later be named titanium by the German chemist Martin Heinrich Klaproth, inspired by the Titans of Greek mythology, powerful gods who symbolized endurance and strength. But despite its early discovery, titanium remained more of a scientific curiosity for over a century. The reason? It was incredibly difficult to extract. Titanium doesn't exist in its pure form in nature. It's locked tightly inside minerals such as ilmenite and rutile, forming some of the strongest chemical bonds found in the Earth's crust. Early chemists found it nearly impossible to separate titanium metal from its oxygen bonds. It wasn't until the 20th century that technology finally caught up with science and allowed us to harness titanium's true potential. Today, titanium-bearing ores are mined in countries like Australia, South Africa, and Canada. The process begins with extracting and refining these ores to produce titanium dioxide, a white powdery compound. Ironically, this same compound is used in paint, sunscreen, and even food coloring. But when used as a raw material for metal production, titanium dioxide becomes the starting point for one of the most complex and fascinating industrial processes in modern science. The making of titanium, the Kroll process. Producing pure titanium metal is no simple task. In fact, it's one of the most challenging metals to extract. That's where the Kroll process comes in, a revolutionary method developed by metallurgist William Kroll in the 1940s. Even today, it remains the main process used to produce titanium worldwide. The process begins by reacting titanium dioxide with chlorine gas and carbon at extremely high temperatures, around 900 degrees Celsius. This reaction produces a colorless, highly reactive liquid called titanium tetrachloride. Because of its volatility, workers in the titanium industry even have a nickname for it: tickle. This titanium tetrachloride is then purified through distillation, which removes impurities like iron, silicon, and vanadium. Once purified, it's ready for the crucial next step: reduction. Inside a sealed, oxygen-free vessel, the tetrachloride is mixed with molten magnesium and heated to about 800 to 900 degrees Celsius. Over several days, a chemical reaction occurs where the magnesium steals the chlorine atoms away, leaving behind a porous, sponge-like mass of metallic titanium. This product, known as titanium sponge, is the first form of pure titanium metal. But it's not yet usable. It's fragile and filled with residual magnesium and magnesium chloride. To purify it further, the sponge undergoes vacuum distillation to remove these remaining byproducts. Finally, the titanium sponge is melted down in an electric arc furnace, often under a vacuum or inert gas, to form solid metal ingots. These ingots can then be rolled, forged, or shaped into everything from aircraft parts to medical tools. It's a slow, energy-intensive, and expensive process, but the result is a metal unlike any other on Earth. Why titanium is so strong and unique. Titanium's incredible strength comes from its atomic structure and the way its atoms bond together. It has a hexagonal, close-packed crystal structure, which gives it both exceptional strength and flexibility. In simple terms, titanium is as strong as steel, but about 45% lighter, giving it one of the best strength-to-weight ratios of any known metal. One of titanium's most remarkable traits is its corrosion resistance. When titanium comes into contact with oxygen, it immediately forms a thin layer of titanium oxide on its surface, a natural shield that protects it from rust, acid, and even seawater. This makes it ideal for use in marine environments, chemical processing plants, and medical implants, where other metals would quickly degrade. Another unique property of titanium is its biocompatibility, meaning it doesn't react with the human body. That's why titanium is commonly used for artificial joints, dental implants, and bone plates. It can stay inside the human body for decades without causing irritation or corrosion. And because of its ability to withstand extreme heat, titanium is used in jet engines, spacecraft, and missile casings, where temperatures can soar beyond 600 degrees Celsius. In short, titanium is strong, light, rust-proof, and safe, a combination that no other metal can quite match. Titanium, the metal of the future. So why is titanium often called the metal of the future? Because its unique properties make it vital for technologies that push human innovation forward. In aerospace engineering, titanium's strength and lightweight nature make it essential for building aircraft, rockets, and satellites. It reduces fuel consumption while maintaining durability, a perfect balance for modern aviation. In the automotive industry, titanium is used to create performance parts in sports cars and electric vehicles, where weight reduction leads to higher efficiency. In renewable energy, titanium is being used in wind turbines, desalination systems, and solar technologies due to its resistance to corrosion. Even luxury goods, from high-end watches and smartphones to bicycles, are adopting titanium for its sleek appearance and unmatched durability. But perhaps the most exciting reason titanium is the metal of the future lies in ongoing technological breakthroughs. New production methods like the FFC Cambridge process are being developed to replace the expensive Kroll process. This new approach uses electrolysis to directly convert titanium dioxide into metal, cutting costs, reducing environmental impact, and potentially making titanium as affordable as aluminum in the coming decades. When that happens, titanium could revolutionize industries across the globe. Titanium's legacy and impact on the world. Titanium's journey from an obscure mineral to a cornerstone of modern engineering is a story of persistence and innovation. It took scientists centuries to unlock its secrets and decades more to perfect its production. Today, titanium stands as a symbol of human ingenuity, a material that embodies strength, precision, and progress. Its applications continue to expand. From deep-sea submarines exploring ocean trenches to spacecraft hurtling through the vacuum of space, titanium is proving its worth in the harshest conditions imaginable. In medicine, it's improving lives through implants and prosthetics. And in technology, it's becoming the face of modern design, strong, sleek, and enduring. Titanium isn't just another metal. It's a fusion of nature's power and human creativity, a material that represents where we've come from and where we're headed. It's no wonder it's called the metal of the future. Because as we continue to explore the boundaries of science, space, and technology, titanium will be right there with us, strong, shining, and ready for whatever comes next. Thank you for watching. If you enjoyed uncovering the hidden stories behind everyday things, don't forget to like, share, and subscribe to Janasco. Hit the bell so you never miss a new discovery. Until next time, keep exploring the world's surprising backstories.